Okay, the plan below is drawn to a scale of 1 to 200. Now, many of you guys had the question, 1 what? 200 what? But actually, that I tried to sort of make clear to you guys, it really doesn't matter. 1 something to 200 something. But as long as that's the same unit, right? 1 distance on the map is equivalent to 200 times that distance in the real world. Okay, so it could be 1 millimeter to 200 millimeters, or it could be 1 centimeter to 200 centimeters, or 1 kilometer to 200 kilometers, or 1 light year to 200 light years. Okay, it's not, these are distances, and it doesn't matter what the unit is. But when we measure it, we'll then use what unit we've got. So I measure that as 5.4 centimeters, or 54 millimeters. I'll go for 5.4 centimeters. Now I'm going to draw that on there. And then, so the length of the workshop is 200 times that. That's what this scale 1 to 200 means. So I'm going to do 5.4 times 200. And that gives me 1080. Now if you had this as 5.3 or 5.5, and then you've got the correct working out here, I will allow it. So it's 1080 centimeters. But we want to convert that to meters. So that's the same as 10.8 meters. Okay, because to convert from centimeters to meters, we're going to divide by 100. Because there's 100 centimeters in each meter. Width of the workshop. I make that as 2.7. So I make that width there 2.7 centimeters. So exactly the same thing. I'm going to take 2.7 and I'm going to times it by 200. So 2.7 times 200 equals 540 centimeters in the real world, which is 5.4 meters. Exactly half the length. The area of the workshop. Right, this is the real area of the workshop. So I want to use these real meter measurements. We know that for a rectangle it's the length times the width. So it's just 10.8 times by 5.4. So 58.32. Oh, yeah, 0.32 meters squared. And then if you round that, that's fine, to 58.3 or to 58, that'll be okay. The area of the store. Okay, so the area of the store I've got to work out. So I need to work out both the length in the real world and the width in the real world of the store. So my length here is, I make that 2.4 centimeters. And my width here I make as 1.0 centimeters. So each of those I'm going to times by 200. So 2.4 times 200 is, so this is 480 centimeters, which is 4.8 meters. And this is 1 times, what do we reckon 1 times 200 is going to be? 200. 200 centimeters, which is 2 meters. So the area of the store is going to be 2 times by 4.8, which is 9.6 meters squared. Question 2. Use a scale of 1 to 50 to draw an accurate plan for this room. Now the plan for this room I'm going to want to draw accurately on my paper. And in order to do that, firstly, I'm not going to be able to draw easily in meters, so I'm going to write all these lengths in centimeters. So this is 400 centimeters, this is 350 centimeters, this is 225 centimeters, this is 150 centimeters. Now I'm going to just fill in the remaining side lengths here. So if that's 350 and that's 150, this one must be 200 centimeters. in order that these two side lengths together add up to that one. And if that's 400 and that's 225, this must be 400 take away 225, which would be 175 centimeters. Okay, so this is then the drawing I need to do. Except I'm not going to draw 400 centimeters because that would be 4 meters worth of drawing, and that's way too big. So I have to use this scale. So 400 in the real world, on the map that I'm drawing, it's going to be 1/50th of that. So I'm going to have to divide each of these lengths by 50 to find out, how long I'm going to actually draw it. So let's do that here. So I got 400 divide by 50, and that gives me 8. So it's going to be 8 centimeters there when I'm drawing it in the plan. 350 divided by 50, it's going to give me 7 centimeters there when I'm drawing it in the plan. 225 divided by 8 is going to give me 28. Hang on, 225 divided by 50. Didn't think that was right. Didn't sound right. 4.5. 4.5 centimeters. 200 divided by 50 is going to give me 4 centimeters. 175 divided by 50 is going to give me 3.5 centimeters. And 150 divided by 50 is going to give me 3 centimeters. So I've now worked out all of the side lengths that I need for this drawing, and so now I can do the drawing itself. So the top one was 8 centimeters, so I go to space in my book, and I want 8 centimeters there, so this is question 2, and the top there is going to be 8 centimeters long. Okay, that is the same as 4 meters. I've drawn 8 centimeters exactly. Then I'm going to need 7 centimeters down here. So that's 3.5 meters. Then I've got this 4.5 centimeters along here. Luckily, our book's in nice half centimeter squares, so that helps us. So that's 2.25 meters. And then I want 3 centimeters this way. So 1, 2, 3. That's 150 centimeters or 1.5 meters. Then I want 3.5 this way, and that's 101.75 meters. And then I want the rest this way, and that's going to be 2 meters, and that's it, correctly drawn. Question 3. A length is given as 340 centimeters, correct to the nearest 10 centimeters. What are the upper and lower bounds of the length? So what this means, which I know we've not actually covered, but what this means is something has been rounded to 340, okay, to the nearest 10 centimeters. So what would be the smallest it could be? Well, the lower bound is the smallest it could be. So the lower bound would be equal to 335, because that's the smallest amount which would round up to 340. The upper bound, and this is going to catch most of you out, I guarantee, until I explain it in more detail. The upper bound is actually 345. Now I know you guys think, hang on sir, 345 rounds up to 350. But 345 is the upper bound. And the reason is that we would say that the length would be greater than or equal to, so if this would be the length, it's greater than or equal to 335 and less than 345. But I can't give anything less than 345 because I could always think of something a little bit higher than that. So, for example, 344.9, I could think of 344.99. 344.99999, I could think of 344.9999999, etc. A map is drawn with a scale of 1 to 20,000. What actual distance in meters does 1 centimeter on the map represent? So it's 20, if 1 centimetre on the map, it's 20,000 centimetres in the real world. Now 20,000 centimetres is the same as, I need to divide by 100 to change centimetres to metres, so it's 200 metres. Next question. What actual distance does 2.5 centimetres represent on the map represent? Well, it's going to be 2.5 times by 20,000, which is 50,000 centimetres, which is 500 metres. What distance on the map represents an actual distance of 1 kilometre? Well, hang on, I can just use this piece of information. If 500 metres is 2.5 centimetres, then 1 kilometre is going to be twice that. So 1 kilometre is going to be 5 centimetres. Now there would be another way of working that out, which would be to take 1 kilometre, which is 1,000 metres, and divide that by 20,000, because that's your, so 1,000 metres, which is the same as 100,000 centimetres, and to do 100,000 divided by 20,000, and you'll still get 5 centimetres. What distance on the map represents an actual distance of 12 kilometres? So we've got 12 kilometres, which is 12,000 metres, and I need 2 extra zeros if I'm timesing it by 100 to give centimetres. So it's actually 1.2 million centimetres. In the real world, to convert that to my map, I'm going to divide by 20,000, and that's then going to give me my answer. So 1, 2, 0, 0, 0, 0, 0, is that right? Yeah, 1,200,000 divided by 20,000 gives me 60. It would be 60 centimetres on the map.